Hello, my name is Esthy Gracee Anasumping, and my metrics number is 20244168854. My final year project is titled GIS-Based Air Pollution Monitoring and Complaint System for Public Authorities in Shah Alam. This project was completed under the supervision of GS Dr. Munira binti Radin Muhammad Mokhtar. The system uses ArcGIS Survey 1 to 3 to collect public complaints, ArcGIS Pro to map factory locations, and ArcGIS Online to present the information through an interactive web map and dashboard. The first stage is the development of the air pollution complaint form using ArcGIS Survey 1 to 3. From the My Survey page, I selected New Survey. I then chose Blank Survey and click Get Started to create a new form from scratch. The survey was named Air Pollution Complaint Form. A survey description was added to explain the purpose of the form. It informed the public that the submitted information will help the relevant authorities monitor pollution, identify affected areas, and support environmental decision making. Next, I added a single-line text question to collect the complainant's name. The question was made compulsory to prevent incomplete submission. Another single-line text question was added to collect the complainant's email address. A phone number field was also included so the relevant authorities could contact the complainant if additional information was required. A required date and time question was added to record when the pollution incidents occur. Next, I added a map question labeled Location. Point geometry was selected so each respondent could mark one specific incident's location. The best map was changed to imagery, and tools such as search, zoom, locate, and coordinate input were enabled. This question was compulsory because accurate location required for spatial analysis. An address question was also added to collect the written address of the affected area. A multiple select question was created to identify the types of air pollution. The choices included factory smoke, open burning, chemical odor, and dust pollution. The other option was enabled so respondent could enter an unlisted pollution type. A single selected question was added to record the precise severity of the pollution. The available choices were low, moderate, and high. These categories can later be used for map symbols, filters, charts, and hotspot identification. Another single select question was added to determine how long the pollution has been occurring. The choices included less than 1 hour, 1 to 6 hours, more than 6 hours, and several days. A multiple text question allowed respondents to provide further details about the incidents, such as visible smokes, unusual smells, and suspected pollution sources. The form also asked whether the pollution affected the respondents. If the answer was yes, the respondent could select effects such as difficulty breathing, eye irritation, headaches, bad smells, or reduced visibility. A file upload question was included so respondents could provide photograph, video, or documents as supporting evidence. After completing the question, I select a green environmental theme to give the form a consistent and professional appearance. The thank you screen was enabled to confirm that each respondent has been submitted successfully. The Bahasa Melayu was also added as a second language. This allowed respondents to complete the complaints form in either English or Bahasa Melayu. Under the Collaborate setting, the survey was configured to open directly in a web browser. The Everyone option was enabled so members of the public could submit complaints without signing in to an ArcGIS account. The complaints form can be accessed through a direct web link or by scanning the provided QR code. Finally, the survey was saved and published. It was ready to collect structure and location-based air pollution complaints. The second stage involved mapping the factory location using ArcGIS-Pro. First, the factory data was cleaned and organized in Microsoft Excel. The dataset contained the factory name, industry type, latitude, and longitude. It was then saved in CSV format and added to ArcGIS-Pro. The XY table to point tool was used to convert the coordinate data into special point features. Longitude was assigned to the X field, while latitude was assigned to the Y field. GCS-WGS 1984 was selected as the input coordinate system because the coordinates were recorded in decimal degrees. The Z field was empty because elevation information was not required. After the tool was executed, ArcGIS-Pro created a point for each factory's location. The output was inspected to ensure that the points appeared within the correct Shah area. The resulting point layer was exported into the project geodatabase as a permanent feature class. This ensured that the spatial geometry and attribute information were stored together in a supported format. Finally, the factory features class was shared as a web feature layer named factory location. The sharing settings were analyzed before publication. Although ArcGIS-Pro displayed warning for the basement layer, this layer did not affect the factory points. After confirming that there were no errors, the factory location layer was published to ArcGIS Online. The third stage involved developing the web map and dashboard using ArcGIS Online. In Map Viewer, I added the Survey 123 campaign layer, the published location layer, and the Shah Alam administrative boundary. The layers were arranged so that the campaign and factory points remain visible above the boundary polygon. The symbology was customized to distinguish the different datasets. Factory locations were displayed using a visible point symbol, while the Shah Alam boundary uses a contrasting color with suitable transparency. The complaint points were symbolized using pollution severity. This allowed reports classified as low, moderate, or high to be recognized more easily. The map extend layer order symbols and pops-up were checked before the completed web map was saved. Next, a new ArcGIS dashboard were created using the Save Web Map. The map element provide the main spatial view of complaint location, factory location, and the Shah Alam administrative boundaries. An indicator was added to show the total number of complaint reports. In this project demonstration, the dashboard displayed a total of 17 reported cases. A pie chart was added to compare complaint categories such as pollution severity or whether respondents were personally affected. A serial chart was also included to compare numbers of reports according to different types of air pollution. Finally, the map indicators, pie chart, and serial chart were resized and arranged into a clear dashboard layout. A completed dashboard allows public authorities to review the distribution of complaints, compare pollution categories, examine reported severity, and identify locations that may require further investigation. In conclusion, this project created a complete workflow for collecting, managing, mapping, and visualizing air pollution complaints in Shah Alam. ArcGIS Survey 123 provides an accessible and bilingual complaint channel for the public. ArcGIS Pro converts factory coordinates into useful spatial information. ArcGIS Online combines the complaint data, factory location, and administrative boundary in an interactive web map and dashboard. The completed system can help public authorities review complaints patterns, identify potential pollutions, hotspots, and support more informed environmental monitoring and response. Thank you.